Thank you very much. Thank you for the nice introduction. I'm looking forward to 45 minutes of network security and Azure Machine Learning. I would like to emphasize that if you have any questions, please try to make it interactive. You can type in your questions in the chat. I have a second monitor here and I'm continuously monitoring the chat, and if any questions come up, I'll be more than happy to answer them. I already posted a link to my slides to the chat room, so if something is not so easy to read over the web meeting, feel free to check out my slides directly there. Okay, with that, without any further ado, let's get right into it. Maybe some of you don't know me yet, so I think I should introduce myself quickly. My name is Rainer Stropek. I am broadcasting from a beautiful town called Leonding near Linz in Austria. So I'm speaking here from Austria, and I'm a passionate software developer over more than 25 years. I'm not a traditional security specialist. I consider myself a DevSecOps person. So what I do is I write software, I run this software in the cloud, and I'm also taking responsibility for securing the software. So what I do for a living is I'm doing consulting work and training work and developing work together with customers to solve certain problems. And one thing that comes up more and more in the context of cloud is machine learning. More and more companies try to use the hyperscaling nature of the cloud to outsource the operational perspective, and as we will see, also some security issues regarding running their machine learning environment to big cloud providers. And that sparked this idea for this talk in my head. I thought it would be nice to show you what a large world-leading hyperscaler like Microsoft Azure is capable of doing when it comes to securing a machine learning environment which consists completely of platform as a service services, so no virtual machine, nearly no virtual machines. Yes, I will need some demo virtual machines, but in general, all the machine learning is platform as a service, and I would like to show you how this works. I'm a Microsoft MVP and regional director. That does not mean, if you don't know these terms, that I'm on the payroll of Microsoft. You simply get these titles if you do a lot of work with the community, if you write a lot, if you're doing a lot of speaking, and so on. I'm also a trainer, teacher, and mentor, and I have a big heart for the community. I'm co-founder and chairman of the Coding Club Linz. We run a pretty large programming club for kids, Coder Linz. So if you have kids and they speak German and they want to learn coding, then tell them about the Coder Linz. We are more than happy to welcome them. With that, let's skip the introduction part and jump right into one last thing. If you want to keep in touch with me after this talk, please check out my digital CV. It's at the right lower corner here. You will find some links to LinkedIn and Twitter and YouTube and so on. And I'm more than happy to accept your connections. And if you have any questions, the best thing is to use these platforms to get in touch with me. Okay, that's it. So let's jump right into it. And the most part of today's session will be demo. I have just 2 overview slides, which should make it easier for you to understand what's going on. Let me quickly describe the first scenario that I'm going to discuss together with you. Here we have the Azure Machine Learning environment. Azure Machine Learning comes with a bunch of functionality, and today I will just focus on one aspect of it, running Jupyter notebooks, so running Python in Jupyter notebooks to do some simple machine learning stuff. We will not deal with machine learning so much, to be quite frank with you. We will focus on the security aspect. Now, this Azure Machine Learning thing is accessing storage. Azure Storage is a platform as a service, to be more exact, a serverless service where you can store files and data and your data lake and things like that. And that's just an example for one kind of storage. The principles that I'm going to show you in a bunch of minutes apply equally to relational databases, to NoSQL databases like Cosmos DB with the Mongo API and things like that. So storage, here it is really the service called Azure Storage, if you're not familiar with Azure. But it's more an example for any kind of storage where you have your precious data stored. Of course, we need to secure this. Then we need a service which is called Key Vault. Key Vault is a secure place to store secrets, and I will show you how we can securely access the Azure Key Vault from within Azure Machine Learning, especially from within Jupyter notebooks, from within Python scripts that you might use for automating machine learning processes and so on. And last but not least, I will show you how to access big scale data stores. In this case, again, storage. It will be a data lake. And everything is embedded into a single sign-on, into a single directory system, which is called Azure Active Directory, which we will use for human sign-in. So signing in using multi-factor authentication through interactive portals, and also for machine-to-machine communication. My goal in this first sample is to show you that we can communicate between Azure-ML, Storage, Key Vault, and all the other services without any password at all. I will have some passwords, but I don't need them, and this is what I'm going to show you. Okay, that's enough for the introduction. Let's jump into the demo. Okay, here it is. I put my slides to the side, and I have some notes here what I want to do with you. Okay, this is the Azure portal. If you are not familiar with the Azure portal, here it is. And my first demo here is this ML public. Here I have pre-published a machine learning workspace. This is how a machine learning workspace looks like in Azure. The beautiful thing here is that it's completely platform as a service. It's completely PaaS. Okay, and I signed in to this portal using my credentials, my Active Directory credentials, and of course I used multi-factor authentication. That's clear. Now let's run Machine Learning Studio in this area here. And here you see the portal of Machine Learning Studio. Again, single sign-on. I have no specific additional sign-on. So single sign-on is really important. I can't emphasize enough how important Azure Active Directory is if you want to do anything in Azure. If you want to use Azure, you should definitely put the focus on Azure Active Directory, because this is where all your precious accounts are, where your permissions are. So you have to train your Azure Active Directory muscle if you want to go in this direction, of course. Now let me quickly show you how this stuff works. Azure Machine Learning Studio knows a bunch of things. I only have 45 minutes, so I will focus on the first one as an example for how to secure this stuff. And here I have prepared a Jupyter notebook. A Jupyter notebook, for those of you who are not familiar with it, it's a nice combination from markdown documentation and executable code. And in this case, it's Python code. And I want to use a bunch of Python code snippets to demonstrate some topics concerning security. Now you might ask yourself, where is this code really running? And the answer for that is hidden behind this compute thing here. This compute thing in Azure Machine Learning allows us to generate new compute instances, as you can see here, with various sizes. We can define whether we need GPU support or CPU support, whether we want to have all the options. Then there are a lot of different virtual machine types available, as you can see here. So data scientists can create those virtual machines if you give them the permission on their own. They can create these virtual machines. These virtual machines can be accessible through a web-based terminal that looks like this. Let me show you that. I can go here. And as you can see, I'm spinning up a terminal, and now I'm using my browser session with my multi-factor auth protected single sign-on environment. Or the other possibility would be to enable SSL access. I did that here, and here you see SSH, not SSL, of course, SSH access, and with that I could use SSH to directly connect to this virtual machine from my computer. I can also use Visual Studio Code to do remote work, so I run my Python environment on my local computer, but all the execution is done inside of Azure Machine Learning, inside of this virtual machine. Is this virtual machine publicly accessible? Yes, it is. As you can see here, it has a public IP address and no virtual network. And this is what we are going to change over the course of this demo. But currently, everything is public. I call this the zero trust mode. So my machine learning workspace is accessible over the public internet. My virtual machine on which I do my Python scratching here, or something like this, is accessible over the public internet. My data store, my storage accounts are accessible over the public internet. The cornerstone of security really are encryption, TLS, are authentication and authorization, Azure Active Directory, and of course, logging and monitoring. Everything can be logged and monitored. So on these three pillars, you could run these machine learning things directly over the public internet. Now let me quickly run those Python things here. Let's run that one. As you can see, what I do here is I do a DNS resolution. I'm looking for the key vault here in Azure, and this is the thing that I meant. We are directly accessing from within Azure Machine Learning, from within our machine learning VM. We access through Python, through Jupyter here, the key vault over the public internet, as you can see here. We can also access secrets in key vaults. I run this and you see here I have a demo secret. I will zoom in a little bit so you see it better. I have a demo secret so I can securely access in a zero trust mode my secrets in key vault from within this Jupyter notebook. And this can of course be used for any kind of secret or certificate, if you have certificate-based authentication, for instance, in a secure way. Maybe you need to access some external data stores that need secrets, API keys or things like that. Or as I said, certificate-based authentication. Then you can use Key Vault to access it. And the beautiful thing here with Azure Machine Learning is that it comes with Key Vault built in. So you get a Key Vault out of the box and it's just a few lines of Python code and it just works. Then we can register data stores. Just a quick overview, what we see here, we are here using the Azure Machine Learning API to register a so-called data lake. If you're not so much into machine learning, a data lake is, as the name suggests, a big lake of semi-structured or unstructured data. Could be images that you want to do some machine learning on top of. Could be some CSV, comma-separated value files, as we have here. In this case, I have a CSV file stored in my data lake. And here I can register access to these data lakes. And again, this is just exemplary for any other storage mechanism, okay? Here I can register my data lake. I have, if you look very closely, I have two register data lake calls. And there is a big distinction between these two. And this is important security-wise, because the first one does not contain one specific setting. This one. The first call to register Azure Data Lake Generation 2 does not contain any kind of secret. So you might ask yourself, how does security work? If you run a Jupyter notebook in Azure Machine Learning, how can we authenticate? And the answer is, if you are inside of the portal, if you are running interactively as a data scientist, you don't need any kind of secret if you are within the Azure universe. Because this is all automatically protected behind the scenes through a series of tokens, JAWT tokens acquired from Active Directory. So the Jupyter environment here will fetch the token for you and pass on the token which is assigned to you as a data scientist to Data Lake. So from a security perspective, that's great because I can define access permissions based on the individual user accounts of my data scientists, and I can exactly specify who is allowed to access which data. This works without any virtual network over the public internet. The second option is the, let's say, old version. Here, as an example, I stored the secrets to access data lake. I explicitly generated a client ID, a so-called service principal, and a secret manually. I took these data, I put them into Key Vault, and I'm getting data out of Key Vault, the secret from Key Vault, and putting it directly into the register Azure Data Lake storage here. So I never see the secret. The secret is stored in Key Vault. And guess how I access Key Vault? Exactly, using Azure Active Directory. I don't need any additional security mechanisms here. Okay, I already performed that. I can show you that here. I already registered these two data lake storages. It's just a matter of seconds, but we will not spend a lot of time. To prove that we can access these things, I'm again using a DNS resolver, and as you can see, I'm also accessing my data lake, my precious data lake, through a public IP address. So we are still in zero trust networking mode. No virtual networks, no isolation, nothing at all. And finally, I can run this one. I will run it again. It will take a few seconds because it has to, for the first time, if I run it for the first time, it needs to get the access token. And does it get the, yes, it took a while until it got the access token. You see it here. This is the data store which doesn't have a client secret, and it fetches the access token from Azure Active Directory and passes on this access token to my data lake, gets the CSV file from there, and then uses a Panda data frame to plot these things. And just to have some fun, I use the Datasaurus data set to display this guy here on the screen, as you can see it here. Now I can switch from this way of working to this way of working. This is the second registered data store here. You see the second registered data store where I explicitly use the secret. And if I run this again, you will see in a second or so, here it is, I got again the Datasaurus. But do you see here, Azure Active Directory is not used to get an interactive token. Here I'm using a service principal, and this service principal it gets again a token, but it's not my personal token as a data scientist. So a service principal is the correct mechanism if we have machine-to-machine communication without an operator or machine learning specialist sitting in front of the computer. Both options are viable. So what should you take away from this short first sample? From this short first sample, you should take away that Azure Machine Learning is a PaaS solution and it can be run in the public internet. Data scientists can, if you give them the permission, deploy their own compute environments with settings and sizes and hardware characteristics that fulfill their needs. Of course, as an administrator, you can also keep this permission for yourself, and then you can deploy these compute instances on their behalf and give them access to these machines. Once Azure Machine Learning grows larger, of course, the same applies to compute clusters. And if you want to use Kubernetes to run your machine learning experiments, that's also possible. But I only have 45 minutes today, so please excuse me not going into the cluster topic here. So this is the second takeaway that you can see. And from a security perspective, I wanted to prove first that we are really running over the public internet, and that we do not absolutely need explicit security tokens because we can use the Azure Active Directory and the identities of our data scientists to grab tokens and to access data storages, key vaults, and so on their behalf. That's an important one. So this was the first sample, and it was a short one. The second example will now, and I want to go back to the slides for a second here. Let's get the slides here. I showed you that one. The second example will look similar, but it has a big difference, and this is where I want to spend the majority of my today's talk on. The big difference is that now, in this second example, we do not run everything in a zero trust networking way over the public internet, but we will try to encapsulate everything in a virtual network. And we want to protect ourselves not just with Azure Active Directory, with encryption and all this stuff, but we want to add a second and an additional layer of security by doing additionally perimeter security. So we will lock down our virtual network in Azure. How does that work? Here on the left-hand side, you see Azure Machine Learning, you see storage, you see Key Vault, and we will also talk about DNS in a second. Now, we cannot move the Azure Machine Learning stuff into our VNet. We cannot move storage into our VNet. We cannot move Key Vault into our VNet. That's not possible because these services are platform as a service offerings. They are run by Microsoft in a multi-tenant fashion. They run in Microsoft's infrastructure, and we cannot move them out into our VNet. So we can't protect them? Of course we can protect them. We can use a technology which is called private endpoint in the Microsoft universe. So this here symbolizes this private endpoint or private link. They are closely related to each other, and for the sake of simplicity I will just use the term private endpoint here. So we can create private endpoints which will give us local IP addresses for these platform as a service offerings within our VNet. And then we can configure these services here on the left hand side so that they are no longer accessible from the public internet. That means if somebody wants to access our machine learning over the public internet, it simply doesn't work. It is technically possible, so it has a public IP address, but it is not accessible. Nothing is open there. We can ignore this one. And the same is true for all the other services that you see here. But we can definitely access our private endpoints from within the virtual machines that we deploy using Azure Machine Learning. But this time we go through local IP addresses and have the virtual machine running inside of our VNet and therefore being protected from being accessed over the public internet. It's no longer possible to access these virtual machine or machine learning or storage or Key Vault or whatever you use. So it's encapsulated in this virtual network. Now you might ask yourself, what is the value of all this? If I have everything locked down, I have locked down my data scientist virtual machine, I have locked down access to storage and Key Vault, I cannot access anything. It's worthless, isn't it? Well, in practice, of course, this VNet is not alone. What you could do, and let me draw a little bit here, if this is your local area network, for instance, in your corporation, for instance, what you could do is you could create a VPN. You could create a VPN gateway in Azure and connect it through a site-to-site VPN. That means that your data scientist who might sit here can go through the VPN tunnel into the VNet in Azure and access the virtual machine, and from there securely access machine learning, access storage, and access Key Vault. That is one possibility. The other possibility, and for simplicity, because I only have 45 minutes a day, is to create a jump host machine. You could create another virtual machine here and use a service which is called Azure Bastion, which allows us to access this jump host machine without opening any port. What we essentially get is we get a web-based portal through which we can use either SSH or RDP to access the jump host, and from the jump host we are now in the VNet. So maybe your data scientist is working from at home. The data scientist, for whatever reason, doesn't have access to your corporate network. Therefore, she cannot go through the VNet, through the VPN tunnel, sorry. In this case, Bastion comes in handy because the data scientist can use the Azure portal, can use multi-factor auth with Azure Active Directory to sign into the Azure portal, and then from within the browser, even from a private computer, can securely access the Bastion host, which does RDP for us, and then we are in the VNet, and then we can do whatever we want. And this scenario is what I built for you, and I would like to show you how this scenario looks like. That will be the rest of the demo today. So let me get rid of the slides here, and let's get back here to my resource group, and now we go into the machine learning private resource group. The first step that I already did, because it takes approximately 10 minutes or so, is I already deployed Azure Machine Learning for you. I can quickly sketch that. Let me quickly, this is a live demo, and the rest is okay, networking, and this is where I changed from sample 1 to sample 2. In sample 1, everything is public. The machine learning stuff was public, the storage stuff was public, the key vault stuff was public. It was zero trust networking, solely relying security on authentication and authorization, encryption and logging and monitoring and telemetry. But now for the second demo, I switched to private endpoint. And with private endpoint, I can here connect my machine learning environment with a virtual network. And this is the virtual network that I created here. You see, I have a virtual network, I can create subnets, and I can do a lot of security stuff on the networking level, which I will not go in any details here because I repeat myself, I only have 45 minutes. So if you are interested in that, check out Azure's VM capabilities. But there is another thing here on the screen which is kind of interesting. This is that one. Integrate with private DNS zone. This is important because if you run everything within a VNet, we have to make sure that if somebody accesses our machine learning environment or storage environment or key vault environment, that the DNS names are translated not into the public IP addresses, but now in our isolated scenario into local IP addresses within our VNet. So we want to redirect the DNS name not to the public IP address, but to the local IP address to make sure that traffic flows within our VNet and does not go over the public internet, because we want to lock down access through the public internet. And this is exactly what I did. Luckily, this DNS configuration is provided, as I said, platform as a service, is provided by Azure, and we don't need to create it by hand. So let me show you what I already did. Here you see this Azure Machine Learning environment, and if I go to networking, you see that we have this private endpoint set up. What is the consequence here? Now let's go back here to our machine learning environment and try to launch the studio. I'm now sitting here in my office in Leonding in Austria, and I'm simulating the machine learning expert who wants to access the machine learning studio and the notebooks and compute environment, and here you see it, it simply doesn't work. See? It doesn't work. Your administrator has disabled connectivity to your workspace instance from public internet. It doesn't work. I cannot access it. I need to be within the VNet. And this is exactly what we are going to try now. So, in a corporate scenario, I would now have a VPN gateway through which I can access everything. But here I have for the sake of simplicity, created a jump host server. So I created a Windows 10 client here in the Azure cloud, and as you can see, this Windows 10 client is not accessible over the public internet. It's also just within the VNet. But I can now use the previously mentioned Bastion service. So let's use Bastion here and enter my username. I hope I didn't type it in wrong. Let's see. And here we are. So as you can see, I'm here inside. We can close these guys. We will open them later. Here we are. Give me a sec. Here we're good. So I'm now in my browser, and in my browser, I'm using RDP on my jump host, which is not accessible over the public internet. So I have a browser-based RDP session into my VNet. This machine here, this Azure machine, is running inside of my VNet. And now let's try to access Azure Machine Learning from within our VNet. And that would be the case if we would be a machine learning specialist who sits inside the corporate network with an active VPN connection, or in this case through the jump host. And now you see no error, everything is okay. This is what I wanted to make clear here. Now let's jump into the notebook. By the way, here, compute. Here you see, again, the same as before, my compute machine. Now let's jump into the notebook, and I have exactly the same notebook here as you have seen before. So this is exactly the same code. I'm here in the private environment, as you can see. So let's run the first one. Let's run it. And this is not what I expected. Yeah, here. Oh, sorry, I made a mistake here. I didn't change that one to private. I'm sorry. But now I'm in the private deployment, and this is what I expected. Now it looks good. This is our key vault, just as an example, but please use your imagination here. This could be any PaaS service that you want to enable your data scientists to work with. Key vault, data lake, Cosmos DB, SQL databases, Postgres databases, whatever you want to deploy in Azure. You could even use a Kubernetes cluster. You can use your own virtual machines where you run any service that you want. You can put it into the VNet, either directly, if you have a virtual machine, or through a private endpoint, as you've seen before. And now, suddenly, this KVML private vault Azure Net resolves to a local IP address inside of our VNet. Don't get me wrong, this name here, it is definitely accessible over the public internet. So if I go on my local machine and I say NSLOOKUP, for instance, or dig on Windows, on Linux, it doesn't matter, then you will see that this guy has public IP addresses. Yes, it has public IP addresses. But the DNS zone inside of my VNet is now taking over control. And if somebody inside the VNet is resolving this name, the result will be a local IP address. If somebody outside of the VNet will resolve the name, the result will be the public IP addresses. And of course, I have locked down my, for instance, key vault or whatever I have here, so that nobody from outside can access it. I can show you that if I go to key vault and go to networking. Here it is. You can see that I have defined that this thing is only accessible through private endpoints. I could also add some additional networks, but as you can see, no networks are selected. So this is the only really important thing. So there is a public IP, but it is useless because the public IP endpoint will decline. All incoming traffic will say, no, I'm only accessible over the private endpoint. And this is what we have seen here in our notebook. DNS resolution works within the VNet. Now, if you have data scientists who work in the corporate network, then of course you have to configure your local DNS servers in your corporate network accordingly so that they will forward DNS requests for Azure to your local DNS zone in your VNet in Azure. And from there, you forward it to the Azure DNS servers, and they will then they will then resolve their names properly to local IP addresses and not public IP addresses. Okay, so proof that this will still work. We can access demo secrets still. Now you might ask yourself, does it work with storage too? Let's check how storage configuration looks from a networking perspective. Here I have my Azure Data Lake Storage. You see ADLS, Azure Data Lake Storage, with my precious Datasaurus CSV file in. Imagine this would be the most secret data file that you have, and you want to base your very sophisticated machine learning algorithms on it. Now, if we try to access this guy, here it is, we will get, here it is, our Datasaurus data here, because I am inside of my VNet. Now let's copy this one out and go out. This is now on my personal machine in Leonding. I am no longer inside the VNet. And try to access the same thing here. Boom, here we are. See? We are not authorized to perform this operation. Trust me, I have signed in with the same credentials on my computer and through Bastion on my jump host. So it is not a question of personal access permissions. This is now the Azure networking preventing me to access this data through a public endpoint. Yeah? This is the important thing here. So if I go back here, it does work. It uses the data scientist's identity and has an additional layer of security with perimeter security where we can lock down access to a certain VNet. Now, if we go into our notebook, I can easily now register these data sources. The code is identical, what you have seen before. The thing that changes is, again, the DNS resolution for my data lake storage private, because now, again, I'm accessing my data lake storage private through the private IP address. So it is possible to access it. So if we go through that, then we access our data store through a local IP address and not a global one, not a public one. This is what I meant. Let's take a little bit closer look. We have 10 minutes left, I think. Let's take a little bit a closer look at how this DNS works. Let's check the virtual network. Here is my virtual network. And in this virtual network, you see here, I have an Azure provided DNS server. Okay? I could create my own custom DNS server. If I want to build something fancy on my own, I can. But in this talk, I want to focus on platform as a service. I don't want to do any additional work, which I don't have to do. So let's go back. Let's take a look at the DNS zones. Here is the DNS zones. And the last thing that we took a look on was Azure Data Lake. So let's take a look at the private link, at the private endpoint DNS zone for Data Lake. Let's check that one. And if we take a close look here on virtual network links, then you see that I have my DNS zone, which was created automatically once I said only accessible through private endpoint. It was created automatically, but it is linked to my virtual network. So if somebody within my virtual network resolves the name of data lake storages which are registered for private endpoints, then this DNS zone will kick in. And if I go to overview, you will see that in the private here, this is the private, this is the data lake storage, here will deliver the IP address 10.0.1.10. And if I go to my notebook, you will see this is exactly the IP address that I got here in Python. So this is how it works. If I go back here to my VNet, I can also get a very neat overview about all my private endpoints. And you see, I created multiple private endpoints for instance, storage and key vault and data lake storage and so on and so on. Accessing storage through the private endpoint is not limited to data lake and data that maybe my data scientists use. Also, the internal data, like for instance the notebooks that we created, are stored within storage and are accessed using the private endpoints. Let me prove that to you. Let's go into my storage account here, and here we go to file shares, and here we go to code, users, Rainer, and here we are. See? This is the internal storage area, the file storage, where my Jupyter environment, this is my Jupyter environment, stores the data. So this is the data here, and here you see it on an infrastructural level. So here we see what's going on here. And again, if we go back here, I can take a look at networking, and you see that even my my access here is done through the private endpoint. See? So here we are again going through the private endpoint. So also Azure Machine Learning is using the private endpoint to access its internal data. And last but not least, now we know that we have a private IP address. It would be nice to see whether the access really works, and I can run it, and hopefully if the demo gods are smiling, so far they were, we will again see our beautiful Datasaurus. Let's see, and here it is. This is the Datasaurus now in a completely locked down environment where the Datasaurus, where the data scientist needs to be inside of our VNet and can only access this data in our data lake from within the virtual network. The important things, and let me go back here to the slides because it's time to summarize. Time is flying. Let me exactly do that one. The important point that I wanted to make here is that such environments in Azure are possible even based on platform as a service and serverless resources. Yes, I had a virtual machine, this one, my jump host, but I didn't need it. I wouldn't need it. If I have a VPN in place, either a site-to-site VPN from my corp network to Azure, or a point-to-site VPN from the data scientist's home office into Azure, I wouldn't need this jump host. It would be possible for my data scientist to even connect to my Azure Machine Learning environment through SSH, for instance, or with her tools like Visual Studio Code and so on. So this is definitely possible without VMs. I had a second VM, which was this one here. This VM is the VM where my Python code runs on, but this VM is again deployed by Azure. It is set up by Azure. You as a DevOps specialist, you can define how this VM looks like, and this is typically a short-lived VM. So if your data scientist says, I would need a VM because today I'm doing some experiments, then you can create this VM and then you can drop it again. And if next time the data scientists start working, maybe in a week or so, she can run a new environment and do some interactive work. If the work isn't interactive, but you do large-scale training, then you can replace this virtual machine with a cluster. And again, the cluster would run inside the VNet or would be connected to the VNet through things like private endpoints, for instance. This is what I wanted to show you, and time is really flying. I hope it was interesting for you. Let's do a quick summary and then we open it up for the last 2 or 3 minutes for questions if you have some. Azure PaaS and serverless offerings, they are ready for Zero Trust. So if you don't want to have the complexity of all this VNets and DNS and private endpoints, then you can keep it simple. I mean, take a look here. This is the setup with a Zero Trust network. 1, 2, 3, 4, 5 items, very simple, everything is clear, no problem. This is the setup for the locked down version. I mean, just by looking at it, you see that it adds a lot of complexity. And complexity, as we all know, is also a kind of security risk. So you have to ask yourself, are we ready? Do we want to work with a Zero Trust networking environment, or do we need the lockdown mode as I showed you? Perimeter security isn't a must, but you can do it. You can segment your network, you can do micro-segmentation, and if you want to do that, private endpoints are your friends. They help you to add the additional layer of perimeter security. It is definitely not a silver bullet where I would say everybody needs this kind of network segmentation. If you want to keep it simple, and you have to take a look at your project or organization specific requirements to decide whether you want to go for VNets and private endpoints, or you want to go for a solution that runs in the public internet using a kind of Zero Trust networking approach. Thank you very much for listening. I hope it was an interesting 45 minutes. I have 2 or 3 minutes left for Q&A, so if you have any questions, shoot, I'm here for you. If you don't have questions now, but you might have questions in a few days or weeks, remember you can take a look at my slides. There you find my digital CV under stropek.me, and there you find links to the various social media platforms through which you can get in contact with me.